Hi everyone and welcome to another flight deck to sim tutorial. In today's video I'll be demonstrating a flaps up landing and complete the all flaps up landing QRH checklist. We'll also briefly discuss the flaps and slat systems on the 737, and again, like with all my other tutorials, I must stress that everything presented in this tutorial is purely for entertainment and for non-professional simulated flights. Now let's have a look at the flaps on the 737. Now we all know what flaps and slats are for. They are high lift devices that increase lift and decrease the stall speed during takeoff and landing. Now the flaps on the 737 consist of both leading edge and trailing edge devices. The leading edge flaps consist of 4 flaps and 8 slats, and the trailing edge flaps are double slotted flaps, and they're simply operated by moving the flap lever to the desired position. In normal operation, both the leading edge flaps and trailing edge flaps are powered by hydraulic system B, but there is an alternate flap extension system which you can use in the event of loss of system B pressure, or you can either extend the leading edge or trailing edge flaps independently if one of the systems has failed. Now the alternate flap extension works in 2 different ways. You can momentarily flick the switch down, which will extend all the leading edge devices using the standby hydraulic system, or you can hold the switch down, which will extend the trailing edge flaps using an electric motor. Now the trailing edge flaps can be extended and retracted, but caution must be exercised as the FSEU will not stop any skew or symmetry, but the leading edge devices, once extended, cannot be retracted by the standby hydraulic system. So now we've covered the flaps, it's worth noting that flap issues are pretty rare. I've not had any flap issues in the past 10 years operating the 737, but they could happen. Now you've seen how trailing edge flaps and leading edge flaps can be extended using their respective backup systems using the alternate flap extension system, and you'd complete the applicable non-normal checklist to configure the aircraft accordingly. But the odds of not being able to extend any flaps is extremely unlikely. However, Boeing do have a non-normal checklist and guidance in the flight crew training manual for an all flaps up landing, and that's what we'll be applying to this operational example today. So we're just currently holding southeast of Manchester, Echo Golf Charlie Charlie, at a waypoint called Dane. And about 10 minutes ago, I attempted an approach onto 23 right, and after selecting flap 1 on base leg, absolutely nothing happened. The trailing edge flaps are still indicating up, there's no indication of anything on the leading edge flaps, and we aborted the approach, climbed back to flight level 80 to hold at Dane, and I've actioned a couple of non-normal checklists to see if we can actually get the aircraft configured. Now in the QRH there are several non-normal checklists associated with flaps, and it's really important that you select the right one. Now as the trailing edge flaps are not in the commanded position, you can see have flap 1 selected, and the trailing edge flaps, if I move my head a little bit further down, you can see are currently up. We've actually made the condition statement regarding the trailing edge flap disagree checklist, and what this checklist does, it attempts to configure the aircraft for a flap 15 landing using the alternate flap system. Now if we look here on the overhead panel, you can see that I've attempted to extend the trailing edge flaps electrically by holding this switch down. I did that around 5 minutes ago, and absolutely nothing happened. The indicated position on the trailing edge flap indicator hasn't changed at all, it's still indicating up. Now the QRH checklist in the trailing edge flap disagree checklist says if the flaps haven't moved and the indicated position hasn't changed, we must then go to the trailing edge flaps up landing checklist. Now what this checklist does, it attempts to extend the leading edge devices by again momentarily holding the alternate flap position switch to down. Now we already would have done this as part of the trailing edge flap extension checklist previously, but again we'll repeat the test to see if it works. All you have to do in the real aircraft is hold that down briefly. That should use standby hydraulic pressure to extend the leading edge devices. But if we have a look here at the leading edge devices association panel, there's absolutely no indication of any flaps as well. Also we have no indication of leading edge flaps transit or leading edge flap extension. So having done both the trailing edge flap disagree checklist and the trailing edge flaps up landing checklist, we're then directed by the QRH checklist if there's no indication of the leading edge devices having extended, that we have to complete the all flaps up landing non-normal checklist, which is what we're going to do now. So let's have a look at the QRH for the all flaps up landing checklist. Now with all the QRH checklists, they'll usually have a condition of the objective. It's very important that you carefully read this and make sure you satisfy the condition. condition and understand what the objective of the QRH checklist is. So the condition is the leading edge devices fail to extend and the trailing edge flaps are less than 1. So again, we can see we don't have the leading edge extend light illuminated, and the annunciation panel, you can test it, but you can see it's completely blank. The flaps are up, and the trailing edge flaps are less than 1. They are still in the up position, and you can see how the flap indicator position is still in flap 1. You don't actually move the flap lever unless directed or instructed by the QRH. So step 1 of this checklist says do this checklist only when directed by the trailing edge flaps up landing checklist. That was the checklist I completed previously at the start of this tutorial, so that's been done. Step 2, it says consider burning off fuel to reduce touchdown speed. Now today I simulated only carrying 100 passengers, sort of cheating in a way, and our gross weight's currently 54.4 tons, so I'm satisfied that the gross weight is more than light enough to fly and approach safely. But if you've just taken off and perhaps had issues retracting the flaps, you might want to consider holding for a few hours to burn off the fuel. There's no requirement to land immediately with a non-normal flap condition. At step 3 it says we need to set VREF 40 plus 55 knots. So I have mentioned this to ZIBO. What you should be able to do is put in any flap setting, including 0, and then add, in this case, 55 knots to 127, so 127 plus 55 is 182, so we'll try it. I don't think it will work, but yeah, in the real aircraft you should be able to input that information. It's not working in the ZIBO mod at the moment, but do not despair. What we can do is actually use the speed reference selector to set VREF manually. That way it's going to be the exact same guidance here. So I was practicing earlier. I've usually the speed reference positions in the auto position, so the FMS will be providing all the information to all the applicable speeds for you. We'll set that to VREF. You'll see VREF applies, or is now appeared here on the PFD. If we go to the speed reference select event, and we can actually bug that speed of 182 knots, you can see the speed increasing there on the PFD. So there's 182, and if we move that to set, you can see now on the PFD 182 knots has appeared, and we have the white speed bug as well. And what we're going to be doing is flying 182 plus 5 knots on final approach there. So our final approach speed is 187 knots. It's much faster than it would be for a normal approach as well. And we'll discuss prior to the approach about when we set the final approach speed, because at the moment we're just flying at the holding speed of 210 knots. Step 4 of the non-normal checklist says check the non-normal configuration landing distance tables in the Performance Inflight QRH chapter or other approved source. We have the other approved source. It's the Boeing onboard performance tool. So if I was to bring it up for you here, you can see I've already pre-programmed all the information. Manchester 23 right, dry, surface wind 230 at 10 knots, 15 degrees, QNH of 1013. And you'll see on the non-normal checklist option I've selected all flaps up and the reversers are all operational. Presuming a landing weight of 54 tons, you can already see the landing data here. The approach speed of VREF plus 5 knots, it already agrees with what the QRH checklist said, so we're going to be flying at 187 knots. And you can see on the runway graphic, with order brake 3, we do have sufficient stopping distance, but we're using an awful lot of runway up there, 2,466 meters. Again, I will talk about how we're going to fly the approach with the flaps up shortly, based on the guidance in the flight crew training manual. So based on what the landing performance says, we can select here order brake 3, and we already have the VREF set here on the PFD. Step 5 of the QRH says maintain flaps up manoeuvring speed until established on final approach. So we're going to maintain at least above the up speed here until we're established on the localizer, and then we'll set our final approach speed. But the QRH, again, if I bring it up here, says limit the bank angle to 15 degrees when airspeed is less than the flaps up manoeuvring speed. So if we're flying below the up speed, which we will be when we're established on final, and we have to turn, we must, below the up speed, limit that bank angle to 15 degrees. Now, it's worth mentioning at this point, if we quickly look at the missed approach here into Manchester, it requires an immediate, well, I say an immediate, at 750 feet, right turn. Now, in this situation, you'd advise Manchester that in the event of a missed approach, we do not want to fly this, because we're going to be initially below the up speed. Just request something climbing straight ahead. And so long as there's no terrain issues, they should be able to accommodate that. This sort of missed approach is most likely designed for traffic inbound to Manchester. Lastly then, on the checklist, it just says here checklist complete except deferred items, which we'll complete whilst we're downwind. It's a descent checklist, a go around procedure review. We then have to complete an approach checklist, some additional deferred items prior to landing, and there's also a slightly different landing checklist, which obviously there's no requirement to check that you have landing flaps selected because they're jammed up in this case. Right, so the checklist is complete up to this stage. We'll advise ATC and we'll get ourselves onto vectors into Manchester after passing Dane. So we're currently inbound to Dane. We'll imagine we'll advise Manchester radar we're ready for the approach, and we'll just imagine they're giving us our initial vector onto the ILS approach. Turn right heading 020 degrees and descend to 3,000 feet. We'd also tell them we'd want a slightly longer final just to get established nice and early. Again, we'll cover the guidance with how we're going to fly this approach shortly. So there's heading select and 3,000 feet set. We'll set the QRH, which is 1013, engage level change, and we're passing 8,000 to 3,000 feet. The standby altimeter is all set. We just need to update the FMS. We'll route direct to a waypoint I created earlier. Execute, and you can see, look, you have got VNAV guidance, but we want to get nice and level prior to the approach. Now, I just remembered the platform altitude in Manchester is 3,500 feet, so we'll imagine we'll be cleared down to that altitude. Excellent. Right, let's have a look at the QRH again for the deferred descent checklist. So pressurization, make sure the land altitude is set, and we have 250 set for Manchester. Anti-ice is off, not required. Approach briefing and fuel is discussed. We have 2.3 tons of fuel available. Again, if we have to go around, we'll look at the guidance there shortly after, but we'll commit to Manchester either way. And lastly, it says the IS and altitude bugs are set, so make sure you have VREV 40 plus 55 knots set, which is what we have got set, 182 knots, and the minimums for the ILS 449 feet is set. Now, what comes up next is a go around procedure review. It says do the normal go around, except do the following. Limit bank angle to 15 degrees when the airspeed is less than the flaps up manoeuvring speed, as it mentioned earlier, and accelerate to flaps up manoeuvring speed when you initiate the go around. You can't touch the flaps, they're not going anywhere. Then a normal go around minus the flaps, raise the landing gear, select a roll mode, and then level off at the missed approach altitude. Now, just the approach checklist coming up now. So it says altimeters and instruments are set and cross-checked. So we have the idents, we have India, November, just waiting it for on the right-hand side there. The courses are set, we have the minimums as well, and we've got our fix rings in. So we're just the approach aids to come up identified on the right-hand side, but we have got India, November, checked and set there. Additional deferred items then. So what's different here to a normal approach and landing checklist? Well, verify the fasten seatbelt sign is on, which it is, and the ground proximity flap inhibit switch is in flap inhibit. So if we go here, move this switch to flap inhibit, what that will do is stop spurious too low flap warnings on final approach because the flaps are up. So it's exactly as we'd be doing in the real aircraft. And all we've got left now to do is the deferred landing checklist. But just before I execute that approach, which is what we'll do when we put the gear down, we'll discuss some of the guidance in the flight crew training manual about how we're going to fly that. And we'll imagine we've got a further vector here to turn downwind. Let's go on a heading of 045 degrees. So Boeing do provide some guidance on how to fly an approach with all the flaps up. Some of the things it mentions is to consider burning off fuel to reduce weights, as per the guidance in the QRH. If possible, fly an ILS, which is what we're doing today. It says establish a nice long final, and once you're on final, established on a localizer, reduce to your final approach speed. And prior to glide slope capture, it's really important to lower the gear. If you don't do that, the speed will run away. In fact, in a 737, even with flap 5 extended and the gear up, it's quite hard to manage your speed sometimes. You might have to have excess drag, so we'll make sure the gear's down to cater for that. It says expect excessive rate of descent and lower thrust on final approach. So typically at the landing gates, we need to be ensuring the rate of descent is not in excess of 1,000 feet. It will be in excess of that today, if not at 1,000 feet per minute. So we would brief that to pilot monitoring. That would be the normal case in this situation. It says fly the aircraft onto the runway. Pretty alarming, but the aircraft will have a huge tendency to float. It does with flap 15 single engine. So with the flaps up, if you overcompensate with the flare, you'll just go straight back into the air again. And Boeing simply says fly onto the runway and flare only enough to have an acceptable landing rate. So you don't want to fly it down at 1,000 feet per minute, obviously, but just a small flare, nice and firm, and right within the touchdown zone. After landing, we just want to hold very light forward pressure just to ensure that the aircraft doesn't want to get back into the air again. You might even during the flare have to put the nose down as well to get it into the touchdown zone. And then as soon as you've touched down, you must immediately select reverse thrust to reduce braking pressure to the absolute minimum required to avoid excessive brake temperatures. So we're going to use max reverse thrust, obviously the speed brake, and as soon as stopping's assured, we'll disengage the auto brake and use all the runway available to come to a safe stop. So Manchester radar has sent us nice and far out as requested. We'll get our final intercept heading. I'll imagine they said turn left heading 270 degrees. On that heading, you're cleared ILS 23 right, report established on the localizer. And this nice long final will give us plenty of time to get stabilised onto localizer, and then we can get the gear down nice and early prior to glide slope capture. So here we are, level at the platform altitude. I've extended the centre line just to increase situational awareness. We can also arm Vorlock. We have 20 miles till touchdown as well. And what we'll do, we'll reduce the speed now to the up speed. And we're going to maintain this speed until we're established on the localizer. And then when we're established, we can set our final approach speed, which is 182 plus 5 knots, so 187. So localizer is now captured, runway heading is set, which is 232 degrees. We're now going to start configuring the aircraft. Just got to put the gear down and we could complete the landing checklist prior to glide slope capture. So here comes the gear, that's down, and we can now also bug below the up speed to our final approach speed of 187 knots. Remembering that below the up speed we must limit the bank angle to 15 degrees. So let's have a look at the all flaps up landing checklist, which is what we'd actually refer to it as. So it says here start switches need to be in continuous. They are in continuous. Recall is checked. There's no associated master cautions, which is good. Speed brake armed green lights, and landing gear is down 3 green. Auto brake we have 3 sets, and we've got the flaps, they are up as discussed with no lights or green lights. It says no lights here in the checklist, and the landing lights are on. We'll imagine we have our landing clearance, and all we need to do now is arm approach, and at glide slope capture the aircraft will keep descending normally. And you can already see here the thrust with just the gear down is much lower. We'd usually wouldn't have the gear down at level flight, but you'd expect with the gear down it'd be a bit around 65-70. But once we get glide slope capture, we'll reassess the thrust setting required and the rate of descent needed to maintain this glide slope. So there is glide slope capture. Let's verify the missed approach altitude here, and we've already said it's climbed to 3,500, but we'd advise ATC. We'd have advised ATC that we'd need to climb straight ahead in this situation. And there we are. Down we go on the ILS approach at 187 knots. So one of the things that I would have highlighted, having just jumped into the passenger view there, where they could see the flaps are up, I'm sure most of you watching would probably notice that would be the case. So we would have done a reassurance PA to the passengers, just telling them that, we'd be honest, couldn't get the flaps extended here, but the approach would be a normal approach, flown a little bit faster than usual, and that after landing we might have the emergency services just inspecting the aircraft, and the landing would be quite firm as well. We would have, of course, briefed the cabin crew of this situation too. So here we are, approaching 6 miles. Look at our rate of descent needed to maintain this 3-degree glide slope. As I mentioned earlier, it's around 1,000 feet per minute. Usually it'll be around 750 to 800 feet per minute at around 150 knots. It's approximately 5 times your ground speed is the required rate of descent to stay on a 3-degree ILS. Now again, we want to utilise the automation as much as possible, so I'll be using it all the way down to minimums, and as I mentioned earlier, the flight crew training manual guidance will be following it as closely as possible. We'll be flying the aircraft onto the runway, a very small flare, only enough to allow for an acceptable landing rate, and then make sure we have light forward pressure during the rollout, just to ensure the aircraft doesn't go back into the air again. So below 1,000 feet AGL, we're ready to take control very shortly. Again, everything's stable. We've already mentioned how the rate of descent might be around or in excess of 1,000 feet per minute. So long as it's something sensible, not excessive, we can continue at the landing gate. So there we are, fully stabilised. Discuss the rate of descent, approaching minimums as well. You could already get the impression of the speed we're going. Much quicker. It feels like I'm in Concorde, not a 737. Anyway, approaching minimums. Looking good on the pappies. That's checked.
200.
That's checked.
Minimums.
Continue. We'll now disconnect the autopilot and disconnect the autothrottle. Keep it descending now.
50, 40, 30.
Very slight flare, close, and right on the touchdown zone there. Nice and firm. So immediately speed brakes up, light forward pressure on the nose, reverses, full reverse thrust. Back on the centre line. Auto brake's still working here, and now we're at the normal touchdown speed. We're going to use all the runway available here. There's 100 knots. I can now disengage the brakes. I'm confident we're going to stop and use all the runway available. Still using reverse thrust to slow down here. I'm just coasting now, no brakes applied. There's 60 knots, so I'll bring the reverse to idle and we'll go all the way to the end to vacate, and just using manual brakes as usual to slow down. Right then guys, that's the end of the all flaps up landing tutorial. I hope you found that interesting and learned something new. As I mentioned earlier, the chances of actually having to do this in real life, extremely remote. You'd not only need a failure of the normal hydraulic system B pressure, which extends the flaps normally, but both also the standby hydraulic system for the leading edge devices and the electric motor for the trailing edge flaps. All three failing at once, extremely remote. But the guidance is there in the flight crew training manual, which is what I applied today. And yes, if you enjoyed it, don't forget to like and subscribe as ever to stay up to date with the latest content. And I'll see you on another tutorial or live stream very soon. Bye for now.